Okay, back in chapter 2 we had this interest formula that we used. So should we start out, principal is $40. It has an interest rate of 6% for 5 years. And we stuck it into this formula and got the following. When we have the amount equals, we would have $40, 1 plus 0.06, and that would all be 5 years. And we got out our calculator and we said, hey, let's punch that in. 40 times 1.06 all to the 5th power, and we hit enter and we're like, ooh, $53.53. So we have $53.53. And what has really happened here is on a timeline like this. So we would have $40 starts right here, and then we would have at the end of 1 year, we would have 6%. And what would happen is we'd go this entire year and 6% would whoosh, slap onto that $40. And then we'd have a second year right here at the end of 2 years. We would have another 6% that would come and whoop, and we'd add that 6% on. And we'd do that at the end of 3 years and 4 years and 5 years. And that's what this formula does. Well, most banks will not just compound every year, but they will do it like in a month or in a quarter. So this is going to be compound. We're going to call this compounding interest. And we're going to do it, first we're going to do it quarterly. So, quarterly. So in a timeline like this, if we start with $40, here's the end of the first year, here's the end of the second year, here's the end of the third year. What we're going to do now is, instead of this 6%, which happens during the whole year, we are now going to chop it into 1, 2, 3, 4 pieces. And be like, oh, we're going to take this portion and compound it back into the $40. Then we're going to take this portion and compound it back into the 40-something dollars, and then this, and then this. So each one of these, now that we've broken it up into quarters, it's going to be only 1/4 of 6%, but it's going to happen 4 times as often. And so we get a whole new formula. So pay attention to what goes on here. We're going to have 6% over the whole year, but it gets divided by 4. So we're going to have the exact same thing, but now we're going to have 40 times 1 plus, now instead of 0.06, it's now going to be 0.06 divided by 4. But notice, this now doesn't happen 5 times like up here. It now happens for 5 years, but it happens 1, 2, 3, 4 times each year. So it's going to happen, I'm going to put 4 times 5 right up here. Now we're going to punch this into the calculator and see what we get. So you can see I've now hit 40 times 1 plus, instead of 1 plus 0.06, it's 1 plus 0.06 divided by 4. An order of operations will ensure that that gets done first. To the 4 times 5. And now we hit enter, and we now have almost the same number, but not quite. 5387. So it gave us just a little bit more over the course of the 5 years, 5353 to 5387. So this was called compounding quarterly. Now if we were to do it, so we did this 12 times, that's going to be really hard to draw, but I'll give it just a shot on this first one. So in this first year, there's 1 year, we're going to break it up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different times. We're going to start with $40. Now the 6% has to happen over the full year, so we're going to take 6%, but divide it by 12 pieces this time. So this is going to be 0.06 over 12. This is what's called, this is the annual interest rate. This guy, and this is kind of important, is called the periodic rate, the periodic interest rate, to be able to do that. So this would be if we compound monthly. So we're now going to have A equals 40. Now it's going to be 1 plus 0.06 over 12. So this is going to happen every month. So it's 12 times in the year. And now, how many periods do we have where we're going to be compounding? Well, we've got 12 in each year, and it's going to happen for 5 years. So that's got to be 12 times 5, 60 of them. And that's going to equal, let's pull out our handy dandy calculator. We've now typed in 40, 1 plus 0.06 divided by 12 to the 12 times 5, and we get just a little bit more, 53.95. So this compounding, the more often it happens, you get 1/12 as much interest, but it compounds in and then earns interest the rest of the time. So the more compounding, the better. So we had stuff, this was actually, we called it a simple interest rate, but it is actually compounding every year that would happen. This is called compounding quarterly and then compounding monthly. And let's write down this formula right down here at the bottom so you can see what the formula looks like when you have, we're going to introduce a new couple of variables. N is number of compoundings per year. Compoundings per year. And then, yeah, that's the only thing that really changes. And you'll notice it comes here. We divide the annual rate by this to get the periodic rate, and then we times that by the number of years to get the number of compounding periods. So the new formula looks like this. The amount of investing this much money at that rate with that many compoundings, and here is a new formula that we punch stuff in and punch it into the calculator. So here's our formula for a savings account where we have a lump sum. So this is our P that we put in. We notice that we don't have any payment yet. No payment is going into the savings account, and we'll get to that in just a minute. There is a formula that we have in Excel called future value. Now this future value, or FV formula in Excel, we're going to put some of these things in, but we have to be very careful. This right here, I think we called that earlier periodic rate. That is what Excel wants us to already figure out and put in there. The other one is this, this is the number of periods total, because you have the number of times per year times the number of years. So this is called the number of periods, or INPER. So in the last example that we did, we had that the principal was $40 and the interest rate was 6%, and the number of times per year was 12. We did monthly at the last one, and the number of years was 5. So when we put this in to Excel, it has something that's kind of really cool. It'll do it for us. Excel's a great calculator. One small detail before we go into Excel. Any money that goes away from you, so in this point we're investing money, we're putting it in the bank. This guy we have to put in as a negative. We'll come back to this in a bit when we show you how this works, but we've got to put in a negative number for that. So here we go. Let's show you how this works. We're going to go up here and find the future value. Now you can just type it in like this, future value, and it will find it. Or we can select a category, financial, and use the future value formula. There it is, FV. And we go like this, and it's going to ask us for some things. So the rate, now remember what it wants the periodic rate, so that divided by 12. And look, it calculates it for us right there. That's kind of cool. Now the number of periods, remember this happened 5 years for each month, so 12 times 5 is 60. The payment, now again, we didn't do any payments in this, so this one's 0. Now PV stands for principal value, or our capital P in there. We invested $40. Don't forget, that's a negative $40. And look at what it comes up with. Ka-ching! $53.95. We can just stick it in there like that without any problem, and it already does all those calculations. Okay, so now we're going to look at something. If you have a savings account where you do have a payment, so let's come down here and see what the savings account is. I don't expect you guys to memorize this or even to use this one in your calculator. It looks pretty big. It looks like this. There's the payment amount. Okay, there it is. If you have a savings account and you just start adding like $25 a month right in here, and there's the periodic interest rate, and you can see it in different places in the formula, that is a big formula. And very similar to that, here is a loan formula. Let's put this in red. The payment you must make on a loan, it starts off with your principal value. Wow, and there's your periodic interest rate, and you'll see the number of periods. But you'll notice this is now a negative exponent when you're dealing with the loan formula. And so these, we're going to show you how these work in Excel, and we will not require you to do these on a calculator at all. But look at those formulas. Don't they look kind of big? So we're going to show you on the spreadsheet how these work. For the first one, we're just going to show you what happens if you were to just do, let's do FV. Okay, there it is. What if we did 6% compounded monthly? That's the most common type, so the number of periods. Let's say over the course of 10 years. So we have 120, 12 times 10. And instead of just starting out with $40, let's say we started out with $40 and we ended up putting in another $10 every month. Now, this is a negative $10 every month because it's going away from us. And look at what we end up with. That is our end result, $1,711.57. Now that is how you can just use Excel just as a calculator. But you can also use it to see some really neat things. We're going to watch a savings account grow. So this is the year that's there. And so now we're going to watch something that starts out, let's say we started out with $40. We're going to call it negative 40. And then it has an interest rate of, say, 6%. And it's going to be compounded 12 times. And every month we're going to put in $10. So a payment, we're going to put in $10. So now watch how this thing is going to grow. So here we know that we're going to have to do the rate that they want, which is, this is how we use the power of Excel, divided by that. Good. So there's our periodic rate, and then the number of periods is going to be equal to this times the number of years that we have. Excellent. So we'll call that y right up there. Okay, now here, this is our final amount that we have. Now, this is going to be FV. So again, find FV. Since we've used it recently, it'll be right there. So there's our rate, and the number of periods is right there. We've already found it. The payment is going to be right there, and the principal value is going to be right there. Okay, so that's what we have at the end of the first year. And if we take and copy and paste these guys, Control C, Control V, that's what it is at the end of the second year. Now if we look at these and we just say, let's paste one more. Control V right there. There we go. Now look, we can see it actually growing. So if we highlight these and we now drag this on, it will give us an indication. Let's go up to like 15 years. Uh-oh, we got too much money. It can't tell what we've got there. There you go. So this is where we had 10 years before, and we can watch it keep growing, and we can see all of these things. And if we were to change how much our principal value was, or change our interest rate, or change our payments, we would see these numbers automatically change. So there's a savings plan formula where you can actually watch it grow. Kind of neat. So now we're going to look at a loan formula and see how Excel can help us with that. So if we started out taking a loan for, say, $15,000, I don't know, whether you're buying a small home, large car, whatever it may be, $15,000, and the interest rate is 6% that you are charged on it, you're going to try to pay off this loan in 4 years. And you're going to be making monthly payments, which means this compounding is going to be happening against you now 12 times per year. So we're going to look at that. So we're going to go into Excel and just punch this guy in. And we could do it all at once, but we're going to use kind of the power of Excel to show you where everything comes from. So here we have a loan payment. Our rate is 0.06. That's our annual rate. The number of years is 4. N, number of times per year, is 12. Principal is 15,000. Now, notice this is a positive because when you get a loan, it comes to you. So it is a positive amount. Now, the rate that it wants, the periodic rate, has to be equal to R divided by N. Now, you could have done that manually and just put in 0.05. That's fine. Number of periods is N times Y gives us, there are going to be 48 payments that we're making. So here we're going to set equals. And for the loan formula, we don't use the FV. We don't have a savings account that's getting this. We want to find out what our payment is. So here we're going to find our payment formula is what it uses in, and you'll see there it is, PMT. Or you could go to financial and scroll all the way down to the payment formula, which is right there, and that's good. So it's going to have the same type of thing. You're going to have the rate, the number of periods, the principal value, the final value. Now in this case, we want the loan to be paid off. That means it goes down to 0. So we hit OK. Now notice this is in red, or it was a negative number. That means we have to make a $352.28 payment every time in order to make that come out correctly. And that's how you pay off your loans.